1-point perspective. If you have not done so, you should read chapters 1 through 3. We're going to make a 1-point perspective diagram. Here's a perspective view of the diagram we're going to draw. We're going to set up the station point, the horizon line, center of vision, measuring line, measuring points, and then we will draw a square. There's no particular order in which these things need to be drawn. I like to start with the horizon line first and work out from there. The horizon line can be drawn anywhere on your paper. It just needs to be a straight horizontal line. Here's the horizon line. We also have the center of vision. There's only one of those. It's where the viewer's looking. You only get one because you can only look at one place at a time. You can only have one center of vision in your drawing. And it's straight in front of the viewer. So, but I can put it like anywhere I want along this line. It's going to be on the horizon line. The next thing I'm going to do is set up how far the viewer is from the picture plane. That's this distance. This is a 3-dimensional distance. My piece of paper I'm working on, it's only 2 dimensions. So to compensate for that, we just take this distance and we swing it down and put it here on this picture plane. This piece of paper I'm working on, this is my picture plane. The distance from the viewer to the picture plane is going to be along this line. I can make it as far away as I like. I'm going to make it 1, 2, 3, 4, 5. I'm going to count these inches as units. So this is 5 units. This is where the viewer's eye is. This is my station point. My center of vision, which is also my 1-point perspective vanishing point. And then my horizon line. It's nice to put the cone of vision in early. It tells you how large your drawing can be without distortion becoming too much of a problem. The cone of vision is 60 degrees. It's 30 degrees on each side. So this is the area that I can draw inside of without distortion being too much of a problem. Distortion starts right there. As you move away from the center of vision, things get more and more distorted. This is just a warning sign. It doesn't mean that things you draw inside of it are fine, things you draw outside of it are not going to be good. It's just the farther away you get from the center of vision, the more and more distorted it becomes. The cone of vision is 60 degrees. It's centered around the 1-point perspective vanishing point. The other thing we want to put in here is a measuring line. That's our ruler. Things that are at the picture plane are actual size, including the ruler. The scale on the ruler is a true scale when you put it right on the picture plane. Putting the measuring line on the surface that the objects being drawn are on is usually the most convenient. So this, in this situation, since this person is standing on the ground, and this is the eye level of the person, the horizon line, this is how far the viewer's eyes are from the ground. So when I put my measuring line in, I can put it really anywhere I want. If I come down, I say 1, 2, 2.5 units. The eye level is 2.5 units above the ground plane. To measure things, we need a scale. I used 5 units for the station point, and I used 2.5 units for the eye level. Here are my units for my measuring line. You have to be consistent with your scale. So these are units to the right of the center of vision and units to the left of the center of vision. I also need a tool to measure lines that go to the vanishing point. Horizontally, I can just use my ruler. And the same thing with vertically. I could just set my ruler here and measure up. But lines that go to the vanishing point, those are the tricky ones. You need a special tool to measure those. For 1-point perspective, we use a 45-degree angle line. You get 2. So you get one on the right side, you get one on the left side, and these are your measuring points. They draw 45-degree angle lines in perspective. So if I want to draw a square, and let's make the square 2 units to the right of the center of vision. And I just count over 1, 2. And I want the square to be 1 unit wide. So I'll count over 1 more. Lines that go back in space in 1-point perspective go to the center of vision. So this is 1 unit across all the way to infinity. Any horizontal line I draw between these two purple lines will be 1 unit. It's 2 units from the orange line. Any horizontal line I draw from the orange line is 2 units. Now if I want the square to be 3 units behind the picture plane, then I come over here. I'm going to measure this line. I could do this one. You could do either one. I'm going to do this one, and I'm going to call that 0, and then count over 1, 2, 3. And this is a 45-degree angle line in perspective. Where it hits this purple line, that makes this 3 from here to here. If I stopped over here, that would be 4, because then this would be my 0. 1, 2, 3, 4. This is 4, this is 3. So since this is a 45-degree angle line, it will draw squares in 1-point perspective. For instance, of a plan view of this. You're looking straight down. Here's the horizontal line. This is 1. And here's a line that's 90 degrees to that. This is a true 90-degree corner. This is a 90-degree corner in perspective. If I want this length to be the same as this, all I need is a 45-degree angle line. Now this is 1 also. And I could fill it in, and I have a square. Same thing over here. except this is a perspective 45-degree angle line. So now I have a square in perspective. It's in a very specific spot. We have 2 units to the right of the center of vision where the viewer is looking. We have 3 units back in space. It's 1 wide and 1 deep. And if we wanted to make it 1 unit tall, then you measure up just with your ruler. There's 1 unit tall. If I wanted it 2, there's 2, 3, and so on. You measure up to get height, and then you project it backwards. So here's 1 unit tall. From here, you are just connecting dots. Vertical lines go straight up and down. Splines that are horizontal, they go straight across, parallel to the horizon line. Again, vertical lines again, straight up and down. Lines that go back in space go to the center of vision, the vanishing point.